Blue Origin just dropped something massive. Their upgraded New Glenn rocket can now deliver over 20 metric tons directly to the moon, nearly matching NASA's $2.2 billion space launch system. But here's what's shocking. It costs less than 1/10 the price and lands back on Earth for reuse. Could this be why NASA's eyeing Blue Origin as their lunar game changer? Welcome back to Space Update 24 Hours. Let's dive right in. So, what exactly did Blue Origin reveal? Just days after New Glenn's second successful flight, they unveiled something the industry didn't see coming. They're calling it the 9x4 configuration, and those numbers tell you everything you need to know about the rocket's transformation. The current New Glenn uses 7 BE-4 engines on its first stage and 2 BE-3U engines on the upper stage. The upgraded version? 9 BE-4 engines downstairs, 4 BE-3U engines upstairs. This isn't just an incremental improvement. This pushes New Glenn straight into super heavy territory, standing shoulder to shoulder with SpaceX's Starship while leaving most commercial launchers in the dust. But why does this matter for NASA's moon ambitions? Here's where the numbers get interesting. The 9x4 variant can haul over 70 metric tons to low Earth orbit. That's impressive on its own. But the real headline is what it can do beyond Earth. Over 14 metric tons straight to geosynchronous orbit. And the kicker? More than 20 metric tons on a trans-lunar injection, a direct shot to the moon. Now compare that to NASA's Space Launch System, which manages about 27 metric tons on the same trajectory. Blue Origin's rocket is suddenly breathing down the neck of NASA's flagship vehicle. And remember, SLS costs roughly $2.2 billion per launch. New Glenn? Estimates suggest it'll cost less than 1/10 of that. Think about what that means. NASA's been locked into a budget-draining rocket that can barely fly once a year. Now they've got a commercial alternative that's almost as powerful, dramatically cheaper, and built by a company that's actually landing boosters on ships at sea. Speaking of which, let's talk about that second flight, because what happened on November 13th changed everything. New Glenn lifted off from Cape Canaveral carrying NASA's twin Escapade probes, 2 spacecraft headed to Mars to study how solar wind batters the planet's magnetic environment. But the cargo wasn't the story. The landing was. The first stage booster came screaming back through the atmosphere, fired its engines, and touched down perfectly on the drone ship Jacqueline. Blue Origin became only the second company after SpaceX to nail an orbital-class booster landing at sea. But here's what shocked engineers watching the livestream. When the booster settled on the deck, it looked pristine. The white, gold, and blue paint sparkled in the afternoon sun like it had just rolled out of the factory. No scorch marks, no soot stains. Nothing like the blackened, battle-worn Falcon 9 boosters we're used to seeing. Why the difference? It comes down to chemistry. SpaceX's Merlin engines burn kerosene, which produces soot. Those boosters literally fly back through their own exhaust cloud. New Glenn's BE-4 engines burn methane, a cleaner burning fuel that leaves almost no residue. The result? A booster that looks showroom ready after punching through the atmosphere twice. Now that booster is back at Cape Canaveral, being prepped for its next mission. Blue Origin's targeting 25 flights per first stage. Ambitious? Sure. But SpaceX has already proven it's possible. One Falcon 9 booster hit 31 flights before retirement. The economics of reuse are no longer theoretical. They're operational reality. And Blue Origin isn't stopping with the current design. The upgrades rolling out starting with the NG-3 mission are substantial. Total thrust on the 7-engine booster jumps from 3.9 million pounds to 4.5 million pounds. The BE-4 engines have already hit 625,000 pounds of thrust on the test stand, with projections reaching 640,000 pounds later this year. On the upper stage, the 2 BE-3U engines climb from 320,000 pounds combined thrust to 400,000 pounds. Blue Origin recently tested a BE-3U that hit 211,658 pounds of thrust, making it the highest thrust-to-weight ratio hydrogen engine ever built, smashing past a ratio of 90. But here's the question nobody's asking yet. What if they add a third stage? Blue Origin has hinted at this for years. A 3-stage New Glenn could push past that 27 metric ton threshold and completely match SLS's lunar capability. The concept makes sense. The 9-engine first stage acts like SLS's massive side boosters, but with better performance and full reusability. The 4-engine second stage becomes the workhorse core. Then you add a third stage powered by Blue Origin's BE7 engine, a high-efficiency upper stage that doesn't waste energy fighting gravity and can focus purely on maximizing velocity. Suddenly, you've got a rocket that can do everything SLS does, costs a fraction of the price, and doesn't throw away its hardware after every flight. NASA's watching this development closely. They have to be, because the Artemis program's long-term sustainability hinges on driving down launch costs, and SLS isn't getting cheaper. But cost is only half the story. The real revolution is what cheap, heavy-lift rockets do to spacecraft design itself. For decades, every mission faced the same brutal constraints. Engineers had to squeeze every gram out of their designs because heavy rockets were too expensive. Even as launch prices improved, mass and volume limits forced teams to use exotic materials, custom hardware, and complex engineering just to stay within payload restrictions. Heavier components were often cheaper and more reliable, but missions couldn't use them because they wouldn't fit or exceeded weight allowances. New Glenn's expanded 8.7-meter fairing changes that equation. Spacecraft builders can suddenly use off-the-shelf commercial parts instead of engineering custom solutions. Projects move faster because teams aren't spending months on weight reduction redesigns. And here's the cascade effect. When you can include larger fuel tanks, satellites operate for years longer. Bigger solar arrays and batteries mean you don't need ultra-efficient, ultra-expensive power systems. More mass for radiation shielding improves reliability and reduces failure risk. These improvements ripple through every subsystem, lowering costs and boosting performance across the board. And when mass and power constraints loosen, it becomes easier to fly new technologies that haven't been space-optimized yet. Starship takes this even further. It could launch a single-piece telescope mirror 2 to 3 times larger than Hubble's. No folding mechanisms, no deployment risks, just pure capability. But let's bring this back to the moon, because that's what NASA cares about right now. Blue Origin isn't just building rockets. They're building the Blue Moon lunar lander as part of NASA's Artemis program. New Glenn is the delivery vehicle. The upgraded 9x4 variant gives Blue Origin the margin they need to land heavier payloads on the lunar surface. More equipment, more supplies, more scientific instruments. Every extra ton of capability translates directly into more ambitious surface operations. And if New Glenn can match SLS's performance at a fraction of the cost, NASA suddenly has options. They can fly more missions, they can afford redundancy, they can build a sustainable lunar presence instead of flying a handful of flagship missions and hoping nothing breaks. The timing couldn't be better. China's ramping up its lunar program. They're planning crewed missions to the moon's surface by 2030. NASA needs cost-effective launch capability, and they need it now. SLS gives them power, but kills their budget. New Glenn gives them nearly the same power at a price that makes frequent flights feasible. SLS's performance at a fraction of the cost. NASA suddenly has options. They can fly more missions, they can afford redundancy, they can build a sustainable lunar presence instead of flying a handful of flagship missions and hoping nothing breaks. The timing couldn't be better. China's ramping up its lunar program. They're planning crewed missions to the moon's surface by 2030. NASA needs cost-effective launch capability, and they need it now. SLS gives them power but kills their budget. New Glenn gives them nearly the same power at a price that makes frequent flights feasible. So is Blue Origin replacing NASA's $2.2 billion rocket? Not officially, not yet, but the writing's on the wall. When a commercial vehicle can deliver comparable performance at 1/10 the cost, eventually the economics become impossible to ignore. NASA's already betting on commercial partners for cargo, crew transport, and lunar landers. Launch vehicles are the next logical step. The space industry's entering a new era. Blue Origin's New Glenn, SpaceX's Starship, and several upcoming vehicles are all pushing toward the same goal, launching far larger payloads at far lower costs. This new generation of commercial heavy launchers could reshape the entire space economy. Not just how we get to space, but how we design spacecraft, plan missions, and think about what's possible beyond Earth. Because when launch stops being the limiting factor, everything changes. Larger constellations become economical. Space stations get bigger. In-orbit refueling networks become practical. Moon bases shift from science fiction to engineering challenges. And suddenly, missions that seemed impossibly expensive 5 years ago are on the table. Blue Origin just handed NASA a solution to their biggest problem. Whether NASA takes it and how fast they move will determine who plants the next flag on the moon. So here's what we're really watching unfold. This isn't just about one rocket versus another. It's about whether the future of space exploration belongs to billion-dollar government programs or to commercial companies that can move faster, innovate cheaper, and fly more often. Blue Origin's upgraded New Glenn proves something critical. You don't need to spend $2.2 billion per launch to reach the moon. You can do it for a fraction of that cost, land your booster for reuse, and still deliver 20 metric tons on a lunar trajectory. That's the kind of capability that changes strategy at the highest levels of NASA. China's not slowing down. Their lunar program is accelerating, and NASA knows they can't win a moon race flying SLS twice a year at current costs. They need volume. They need frequency. They need economic sustainability. Blue Origin just handed them exactly that. The question now isn't if commercial rockets will dominate lunar missions, it's when. My guess? We'll see the 9x4 variant flying by 2027, and by 2030, it'll be launching more lunar payloads than SLS ever did. What's your prediction? Will Blue Origin's New Glenn become NASA's primary moon rocket? Drop your thoughts in the comments below. If this video opened your eyes to where space exploration is really headed, hit that like button and share it with anyone who still thinks getting to space has to cost billions. And if you want to stay ahead of the space race, subscribe to Space Update 24 hours and turn on notifications, because this story is just getting started.